Hello everyone, and welcome to today's presentation. I'm excited to have you here. Today, we'll be exploring the topic of preliminary treatment in wastewater, which is the essential first step in water treatment systems. We'll discuss why this initial phase is so important and how it sets the foundation for effective water purification. Over the next few slides, I'll walk you through the key processes and concepts involved. So, let's get started and dive into the fascinating world of wastewater treatment. Let's dive into Chapter 1, Why Preliminary Treatment Matters. This chapter sets the stage for understanding the importance of the initial steps in wastewater management. Preliminary treatment is really the foundation of an effective treatment process. It's the first line of defense to remove large solids and debris that could cause problems later on. Think of it as the screening process that protects the entire system. By doing this early work, we prevent equipment damage, reduce maintenance needs, and improve overall efficiency. This step also helps us control odors and prevent blockages, which are critical for a smooth operation. Connecting this to our overall theme, you'll see that starting right makes all the difference in achieving cleaner water and sustainable practices. So, understanding why preliminary treatment matters is key to appreciating the entire treatment process. Protecting the plant is like having a hidden hero working behind the scenes. When we talk about equipment protection, what we're really emphasizing is the importance of shielding pumps, pipes, and treatment equipment from damage. How do we do that? By removing debris early in the process, we prevent larger issues before they start. Now, let's think about cost efficiency. When we protect our infrastructure, we're not just avoiding immediate repairs, we're extending the lifespan of costly equipment. This means fewer replacements and major repairs down the road, which dramatically cuts maintenance costs over time. And finally, operational excellence. Keeping equipment in good shape ensures everything runs smoothly. It helps prevent unexpected system failures, which can disrupt operations and cause delays. When you connect all these points, it's clear that protecting the plant isn't just about maintenance. It's about ensuring reliable, efficient, and cost-effective operations that support the overall health of our facility. Let's talk about the challenge of wastewater solids. As you can see, wastewater isn't just water. It contains a complex mix of materials that can really threaten the treatment systems we rely on. For example, plastics and packaging materials often find their way into the system, along with rags, textiles, and fibrous materials that can be tough to handle. We also see sticks, leaves, and other organic debris, which can add to the problem. Sand, gravel, and abrasive grit are common too, and they can cause significant wear and tear on equipment. Oils, greases, and floating matter can cause blockages and interfere with the treatment process. Sometimes, large objects accidentally enter the system, which can be particularly disruptive. Now, what happens if we don't treat these materials properly? Without effective removal, these contaminants can cause severe operational problems. Clogging of pipes and pumps is a major issue, leading to system shutdowns. The abrasive nature of some solids causes equipment to wear out faster, increasing maintenance needs. Operational failures become more frequent, and overall, the efficiency of wastewater treatment drops significantly. So, managing these solids is crucial not just for keeping the system running smoothly, but also for ensuring that we meet environmental standards and protect our infrastructure. This is a key part of the broader challenge we face in wastewater management. Welcome to Chapter 2, where we'll explore the core processes of preliminary treatment. This stage is crucial because it sets the foundation for effective wastewater treatment later on. During preliminary treatment, the main goal is to remove large solids, debris, and grit that can cause problems in the subsequent processes. Think of it as the first line of defense, sort of like a filter that screens out the big stuff. By doing this, we protect the equipment and ensure smoother operation down the line. Some key points to remember are the importance of screening and grit removal. Screening helps catch things like plastics, rags, and other large objects, while grit removal targets sand, gravel, and other heavy particles. Connecting this to the overall theme, You can see how these processes improve efficiency and prevent damage in later stages. It's about creating a clean, manageable flow of wastewater that can be treated effectively. So, understanding these core processes is essential for designing and operating a successful treatment system. Let's talk about screening, which is really the first line of defense in protecting our wastewater treatment systems. Think of it as the initial barrier that catches large debris before it can cause any damage or clogging. First, we have bar screen installation. These screens use bars spaced between 1/2 inch and 1.5 inches apart. Their job is to trap big solids like sticks, plastic, or other large debris, preventing them from entering deeper into the system where they could cause problems. Next, there are different types of screens depending on the scale of the operation. Smaller facilities might use manually cleaned racks, which are simpler and easier to maintain. On the other hand, larger plants often rely on automated mechanical screens, which can handle a higher volume of debris more efficiently. Finally, debris removal is a crucial step. The screening process effectively removes things like rags, plastics, paper, and wood, large debris that could damage equipment or interfere with treatment processes if left unchecked. Overall, screening is a vital first step that safeguards the entire treatment process, ensuring everything runs smoothly from the start. Now, let's talk about screening, or as I like to call it, catching the big stuff. Modern automated screening systems are really impressive. They operate continuously to safeguard the downstream equipment. Think of them as the first line of defense, constantly working to remove large debris that could cause problems later on. Every day, these systems filter out tons of debris from municipal wastewater streams, preventing blockages and damage. This is a crucial step in maintaining the overall health and efficiency of the treatment process. It's a perfect example of how technology helps us protect our infrastructure while keeping everything running smoothly. This concept ties back to the overall theme of ensuring effective treatment through smart, reliable systems. Let's talk about grit removal, which is all about settling the heavy particles out of the water. So, what exactly is grit? Grit includes those heavy inorganic solids that can cause serious damage to equipment. Think about sand and gravel, or even eggshells and bones, things that are quite dense. You might also find coffee grounds, metal fragments, and glass particles mixed in. These materials are quite abrasive and can really wear down our system components over time. Now, how do we remove these stubborn particles? That's where grit chambers come into play. These are specially designed basins that slow down the flow of water. By reducing the velocity, heavy particles have a chance to settle to the bottom due to gravity. Meanwhile, the organic matter, which is lighter, stays suspended in the water and can be removed later. One of the key benefits here is protecting our pumps, pipes, and clarifiers. Without removing grit first, these components are at risk of severe abrasive damage and excessive wear, which can lead to costly repairs and downtime. So, effectively removing grit is crucial for maintaining the overall health and efficiency of the treatment process, aligning perfectly with our goal of ensuring a clean and sustainable water system. Now, let's take a look at the different types of grit chambers used in wastewater treatment. First up are horizontal flow chambers. These are traditional rectangular tanks where water flows horizontally at a controlled velocity. The key here is that this setup allows grit to settle out of the water while organic matter remains suspended, making separation more efficient. Next, we have aerated grit chambers. These utilize air diffusion to create spiral flow patterns within the chamber. This aeration helps to separate heavy grit from lighter organic materials more effectively by enhancing the mixing and settling process. Then there are vortex grit chambers. These chambers create circular or vortex flow patterns, often using mechanical paddles or induced vortex action. This circular motion improves grit separation even further, ensuring that the heavy particles settle out quickly and efficiently. Finally, for large-scale operations, automated systems are increasingly common. These systems handle grit collection, washing, and removal automatically, allowing for continuous operation while reducing the need for manual labor. Understanding these different types of grit chambers helps us see how each design plays a role in optimizing the grit removal process within the overall treatment system. Let's talk about comminution, specifically grinding for efficiency. First, we'll look at the grinding mechanism. Grinders and comminutors work by using rotating cutting teeth to shred large solids. These solids then pass through screening systems, which help separate out the smaller particles. Moving on to size reduction, this process is crucial because it reduces particle size to more manageable dimensions. Why is that important? Well, smaller particles prevent clogging issues in pumps, pipes, and downstream treatment units, ensuring smoother operation overall. Finally, let's consider treatment enhancement. When particles are smaller and more uniform, they improve the efficiency of biological treatment processes and sludge handling. Consistent, smaller particles are easier for microbes to break down, making treatment more effective. Connecting everything to the bigger picture, efficient grinding and size reduction are vital steps in optimizing wastewater treatment, helping us manage solids more effectively and improve overall process efficiency. Welcome to Chapter 3, where we focus on operational insights and best practices. In this section, we'll explore how understanding key operational aspects can significantly improve our efficiency and effectiveness. We'll discuss practical strategies that help us optimize daily processes and ensure smoother workflows. These insights are crucial because they connect directly to the overall theme of improving performance and achieving sustainable growth. By the end of this chapter, you'll have a clearer idea of the best practices you can implement to elevate your operations and drive better results. Let's talk about the importance of velocity control when operating screening equipment. Maintaining an approach velocity between 2 and 3 feet per second is crucial. If the flow is too slow, solids can settle prematurely, which can cause blockages and reduce efficiency. On the other hand, if it's too fast, solids might pass through the screens without being properly removed, leading to potential process issues. Now, moving on to routine maintenance. This is key to preventing equipment failures. Regular cleaning and preventive checks on mechanical rakes, chains, and drives help avoid blockages and keep the flow rates running smoothly. Consistent upkeep not only prolongs equipment life, but also ensures the system operates at peak performance. Lastly, monitoring and adjustment play a vital role. By continuously checking the head loss across the screens, we can identify when cleaning is needed before problems escalate. This ongoing monitoring allows us to fine-tune cleaning cycles, maintaining optimal flow and efficiency throughout operation. All these points connect back to our overall goal, keeping the screening process reliable, efficient, and well-maintained for the best results. When it comes to handling screenings and grit, proper disposal is absolutely essential to keep everything running smoothly and sustainably. Once we've collected the solids, we need to handle and dispose of them carefully. For screenings, the first step is dewatering, which helps to reduce both the volume and weight, making transportation and disposal easier. We often use compaction systems to squeeze out any remaining water, which also helps to minimize storage space and costs. Most screenings end up being landfilled as solid waste, but it's important they're processed properly beforehand. Grit, on the other hand, is usually washed before disposal to remove any organic material that might cause issues later. Some facilities are even exploring ways to reuse grit beneficially, which is a great step towards sustainability. From an environmental perspective, proper disposal of these materials is critical. It prevents contamination of surrounding land and water, and it also helps eliminate unpleasant odors that could affect nearby communities. Overall, handling screenings and grit responsibly isn't just about compliance. It's about protecting our environment and maintaining community trust. Let's now look at some common issues that can arise and how we can troubleshoot them effectively. First, when it comes to mechanical screen jamming, a key problem is fibrous materials like rags and textiles wrapping around the rake teeth and mechanisms. This can cause significant downtime if not addressed promptly. To prevent this, installing shear pins can help protect the equipment, and increasing the cleaning frequency ensures these materials are removed before causing a jam. Additionally, considering fine bubble aeration upstream can help separate out the lighter fibrous materials before they reach the screen, reducing the risk of clogging. Next, let's talk about grit accumulation. Excessive grit buildup inside the chamber can reduce efficiency and decrease the available volume for treatment. To combat this, we should adjust flow velocities to prevent grit from settling and increase the frequency of grit removal. It's also important to inspect upstream sources of grit loading, as high grit levels often originate earlier in the process, so addressing those sources can make a big difference. Finally, I want to emphasize that operator training is absolutely critical. Well-trained operators are our first line of defense. They can identify problems early and perform preventive maintenance before issues escalate. Regular training programs, along with documented standard operating procedures, are essential to ensure everyone is on the same page and maintaining consistent, optimal performance. Keeping our team well-trained and informed really makes all the difference in keeping the system running smoothly. In Chapter 4, we focus on innovations and adaptations, which are really the driving forces behind progress. Here, we see how new ideas and creative solutions have transformed the landscape. It's important to understand that innovation isn't just about new technology. It's also about thinking differently and adjusting to changing circumstances. Adaptations allow us to overcome challenges and stay resilient in a dynamic environment. These concepts are central to the overall theme, highlighting how continuous improvement and flexibility are essential for sustained success. By embracing both innovation and adaptation, we can navigate uncertainties and seize new opportunities effectively. When it comes to adapting to industrial wastewater, it's important to recognize that each facility has its own unique waste characteristics. That's why we often need specialized preliminary treatment approaches tailored to these specific needs. For example, some industries deal with particular contaminants that require custom screening solutions. Microscreens, for instance, are excellent for capturing fibers, while perforated plates work well for slurries. Drum screens are typically used in high-volume applications where efficiency is key. Moving on to grit removal, industries like food processing, mining, and manufacturing often encounter variable and heavy grit loads. To handle this effectively, they use multi-stage grit removal systems that include classification and washing processes. This ensures that the grit is properly separated and treated before moving on in the process. Finally, oil and grease are common issues in many industrial waste streams. To manage these, facilities add flotation units, API separators, or dissolved air flotation systems. These are highly effective at removing oils and greases, helping to improve overall water quality and protect downstream treatment stages. Altogether, these tailored approaches highlight the importance of customizing treatment methods to meet the specific challenges posed by different industries, aligning with our overall goal of efficient and effective wastewater management. Let's talk about pre-aeration and flow equalization, two important steps in wastewater treatment. First, pre-aeration plays a crucial role by introducing oxygen into the wastewater. This helps prevent septic conditions, which can cause unpleasant odors and process disruptions. It also reduces hydrogen sulfide, a nasty gas responsible for that rotten egg smell. Additionally, pre-aeration helps separate oils and greases through flotation, making downstream treatment more efficient. Plus, it freshens the wastewater before it reaches the biological treatment stage, setting the stage for better biological processes. Moving on to flow equalization, this step is all about managing variable flow rates from collection systems. By balancing these flows, we can dampen spikes in pollutant concentrations, which are often unpredictable. This results in a more consistent flow to downstream processes. Consistency here is key because it improves overall treatment efficiency and stability. It also protects our biological systems from shock loading, sudden, intense loads that can harm or disrupt these delicate processes. Both pre-aeration and flow equalization are vital for creating a more stable, efficient, and effective wastewater treatment system, aligning perfectly with our overall goal of optimizing treatment performance. Let's take a look at the environmental and regulatory impacts of effective preliminary treatment. First, permit compliance is crucial. By ensuring our facilities meet discharge permit requirements, we can avoid violations that might lead to fines or legal issues. Proper preliminary treatment helps us achieve this by removing solids early in the process. This not only keeps us compliant, but also sets a strong foundation for the rest of the treatment. Speaking of solids removal, reducing the load early on actually lightens the burden on our primary clarifiers and secondary biological processes. This means the entire system works more efficiently, and we can maintain better operational stability. When we focus on proper preliminary treatment, we see improved overall plant performance. It enhances effluent quality, meaning cleaner water is discharged, and it boosts operational reliability, so our treatment plant runs smoothly and predictably. Finally, all these efforts contribute significantly to environmental protection. Consistently high-quality treatment of wastewater ensures that the receiving water bodies are protected, preserving aquatic ecosystems and public health. In essence, effective preliminary treatment is key not just for regulatory compliance, but also for operational excellence and environmental stewardship, tying everything together in our goal of sustainable water management. Let's walk through the preliminary treatment process flow. First, we have screening. This step is all about removing large debris that could clog or damage equipment downstream. Think of it as the first line of defense in cleaning the water. Next is grit removal, where we settle out heavy particles like sand and gravel. These materials are denser and tend to settle quickly, helping to protect pumps and other machinery. Then comes comminution, which involves grinding or reducing the size of any remaining solids. This makes the waste easier to handle and prepares it for further treatment. Finally, we have pre-aeration. This step not only helps with odor control, but also conditions the wastewater, making it more suitable for the biological treatment stages that follow. These initial steps are crucial because they set the foundation for effective and efficient wastewater treatment, ensuring that the subsequent processes can operate smoothly and effectively. In conclusion, building a strong foundation for clean water is essential. Preliminary treatment plays a critical role as the first line of defense in the wastewater treatment process. It helps protect the infrastructure and ensures that the entire treatment system operates effectively. By doing so, we prevent damage to expensive equipment and avoid costly failures down the line. Investing in robust preliminary treatment systems is a smart choice because it saves money over time by reducing maintenance needs, extending equipment lifespan, and improving overall efficiency. Moreover, effective preliminary treatment is key to safeguarding the environment. It ensures that wastewater is treated consistently and reliably, which is vital for protecting our natural resources. Lastly, continuous improvement in technology and skilled operation keeps our wastewater treatment plants efficient, compliant, and prepared for future challenges. All of these points highlight that a strong foundation in preliminary treatment is not just about infrastructure. It's about creating a sustainable, reliable system that supports clean water for everyone.